continue on to the session. So here we are going to discuss about the AIET 3 NEET solutions for class 12 chemistry. Okay. So here I have selected some questions which are very important and which are the questions you feel it very difficult. So let's do one by one. So moving on to the first question. So it is question number 51. The eyes of a reptile pass a visual signal to the brain when the visual receptors are struck by photons of wavelength 880 nanometer. If the energy of 3 into 10 to the power minus 14 joule is required to trip the signal, what is the minimum number of photons that must strike the receptor? So we are asked to find out the minimum number of photons that strikes the receptor. Okay, so we can take this as n. So we need to find out the n. Okay, and we are provided with the energy value E and the wavelength lambda. Okay, so using energy and lambda, we can find out the energy of one photon. Okay, so this is the total energy and we have to find out the energy of one photon. So the energy of one photon is equal to, that is E is equal to hc by lambda. Okay, so where h is the Planck's constant and it is 6.626 into 10 to the power minus 34, and the c is the speed of light, which is 3 into 10 to the power 8 meter per second, divided by lambda, which is 880 nanometer. So nanometer can be written as 10 to the power minus 9 meter. Okay, so now the energy will be equal to 2.25 into 10 to the power minus 19 joule. So this is the energy of one photon. So why we calculated the energy of one photon? Because to find out the minimum number of photons, which is n, the formula used should be total energy divided by the energy of one photon. The energy of one photon. Okay. So we need the energy of one photon to substitute here in this formula. That's why we have calculated. So now the total energy is given in the question, which is 3 into 10 to the power minus 14 joule. And the energy of one photon is 2.25 into 10 to the power minus 19 joule. So the final answer will be 1.33 into 10 to the power 5 photons. Into 10 to the power 5 photons. So the minimum number of photons that must strike the receptor is option B. Option B. Okay. Next, coming to question number 57. 8.56 liter of an ideal gas at STP requires 24 calorie to raise the temperature by 15 degrees Celsius at constant volume. The Cp of the gases. So how to find out the Cp? So we know the relation, which is Cp minus Cv is equal to R, right? So from this relation only we can find out the Cp value, which is R plus Cv. But we don't know the Cv value also, because in the question we are provided with the volume and a standard temperature and pressure and 24 calorie to raise the temperature by 15 degree at constant volume. We don't know the Cp value and also the Cv value. So to find out the Cv value from the given information, we have to take the delta U relation, which is equal to N Cv delta T. Okay, clear? So we are provided with 8.56 as the volume, and we also have 24 calorie, which is the change in internal energy of the system. So in place of delta U, we can substitute 24, which is equal to N. So N is nothing but the number of moles. So the number of moles is equal to the given volume divided by 22.4. So this is the formula to find out the number of moles for this system. Okay. So in place of N, substitute the given volume, which is 8.56 divided by 22.4. And we don't know what is CV. And the change in temperature is 15 degree Celsius. Okay, it is raised. Temperature is raised by 15 degree Celsius. So let me substitute 15 here. So if I solve this, I will get the CV value as 4.187 calorie per mole per Kelvin. Okay. So now we have to substitute the CV value here in this formula to get the CP. So it will be therefore CP is equal to R plus CV. So what is the value of R in terms of calorie per mole per Kelvin? So the R value is equal to 2 calorie per mole per Kelvin. So we can substitute 2 here and the CV value is 4.187, which is equal to 6.187, and it is approximately written as 6 calorie per mole. Okay, so the correct answer is option D. Okay, so the approximate value is 6 and that is the correct answer. Okay. So to find out the term CV, we are using delta U is equal to NCV del T formula. And from that, we are taking out the value of CP. Okay, so CP is nothing but the heat capacity at the constant pressure. Okay, so moving on to the next. The electronic configuration of an element X is 1s2, 2s2, 2p6, 3s2, 3p3. What is the atomic number of the element which is just below the element X in the periodic table? So we need to find out the element X here. So if you see to the electronic configuration, we have 2 electrons in 1s orbital, 2 in 2s, 6 in 2p, 2 in 3s and 3 in 3p. So if I add all these numbers, I am getting the total number of electrons as 15. So the atomic number for the element X is 15. Okay, so the element with atomic number 15 in the periodic table is phosphorus. Okay, and phosphorus belongs to the 15th group in the periodic table. Okay, so we have 15th group elements which starts with nitrogen, phosphorus, arsenic, antimony and bismuth. Okay, so the element X is phosphorus. The element which is below this phosphorus is arsenic. Okay, and if you calculate the atomic number of arsenic, it will be 33. Okay, it will be 33. Okay, so if we want to go from third period to fourth period, we have to add 18 elements, right? So 15 plus 18 will give us 33, and that is the atomic number of an arsenic. So option C is the correct answer for this question. Okay. Next, coming to question number 65, the solubility product of calcium sulfate is 6.4 into 10 to the power minus 5. The solubility of salts in moles per liter is. So, let me take the calcium sulfate and let me dissociate this. If this gets dissociated, it will give calcium 2 plus ion and SO4 2 minus ion. So we have one cation and one anion. So the solubility of each can be denoted as S and S. Okay. And the solubility product, which is denoted by KSP, is given. which is actually equal to the concentration of the cation into the concentration of anion. And the solubility is given for both, which is S into S. It can be written as S square, and the solubility product, which is S square, is given as 6.4 into 10 to the power minus 5. So this is the value of S square, but we need to find out the value of S, which is the solubility. So if I take the root for this 6.4, I can write this as 64 into 10 to the power minus 6, and after taking the root, I will get 8 into 10 to the power minus 3. Okay, and this is in terms of mole per liter, so I can write the molarity unit here. Okay, so the solubility for the given salt is option C. Clear? Next, moving on to the next question. Equal masses of methane and oxygen are mixed in an empty container at 25 degrees Celsius. The fraction of the total pressure exerted by oxygen is the equal masses of methane and oxygen. So equal masses of methane and oxygen are mixed. And we need to find out the fraction of the total pressure exerted by the oxygen. Now for the simplification process, for the calculation, I am going to take the mass of the methane and oxygen as 32. Okay, so let 32 gram of CH4 and O2 each are mixed. Okay, and the total pressure, and let the total pressure be taken as P. Okay, because the mass for both are equals, I am going to take, we can take any number, and I am going to take 32 gram for the calculation process. Okay, now to find out the fraction of total pressure exerted by oxygen, I need the mole fraction. So in the mole fraction formula, we have to substitute the number of moles. So ultimately, first I need to find out the number of moles for both the gases. Okay. So the number of moles of CH4 is equal to mass by molar mass. So the mass of CH4 is 32 and the molar mass of CH4 is 16. Right. For carbon it is 12 and for each hydrogen it is 1. So 32 by 16 is 2. This is the number of moles of CH4. Now coming to the number of moles of oxygen, the mass of oxygen is 32 and the molar mass of oxygen is also 32. Because for one oxygen it is 16. So for O2 it is 32. Number of moles is coming out to be 1 for oxygen. Now to find out the mole fraction of oxygen, it is equal to So how to find out the mole fraction? It is the number of moles of that particular component divided by the total number of moles. Number of moles of oxygen divided by total number of moles, which is oxygen number of moles and also the methane number of moles. So just substitute the values 1 by 1 plus 2, which is equal to 1 by 3. So this is the mole fraction of oxygen. But we need to find out the fraction of the total pressure exerted by oxygen. Okay. So therefore, the pressure exerted by oxygen is equal to the mole fraction of oxygen into the total pressure, which is equal to the mole fraction is 1 by 3 into T. Okay. So the answer is option D. So it is 1 by 3 of the total pressure. Okay. Moving on to question number 69. The molar conductivities lambda naught for NaOAC and HCl at infinite dilution in water at 25 degrees Celsius are given as 91 and 426.2 Siemens centimeter square per mole respectively. To calculate the lambda naught of HOAC, the additional value required is. So to find out the additional term which is being used in this reaction, I have to go for the complete reaction, right? So what is the complete reaction? So to get NaOAC, AC is the acetate part CH3COO minus part. And to get this NaOAC and HCl, we need ACOH, which is already given in the question, and the NaCl. Okay. So only then the HCl will be removed and we get NaOAC as the product. So AC is nothing but CH3COO. Okay, CH3CO. CH3CO. Now, to find out the lambda naught of this HOAC, so what is required? Lambda naught of ACOH or HOAC. So it will be equal to the lambda naught of NaOAC plus the lambda naught of HCl, and I have to take this NaCl to the other side. It is minus lambda naught of NaCl. Okay. So the additional value which is required is the conductivity, molar conductivity of NaCl, in which option C is the correct answer for this question. Okay. Now moving on to question number 71. In a first order reaction, the concentration of the reactant is reduced to 12.5% in 1 hour. When was it half completed? So in the question itself, they are saying that it is a first order reaction. It is a first order reaction. So the half-life is given as 1 hour. So what I need to do to convert the 100% of the reactant to 12.5%, I need to find out the number of steps it is taking, number of half-life. So for 100% to 50%, the T will be equal to T half. It is 1 T half. Okay, because 100% is the initial amount. 100% is the initial amount. And to make half of this, I need half-life as T half. And from 50 to, if I want to move from 50 to half of that, which is 25%, the time required is 2 T half. Okay. And from, if I want to move from 25 to 12.5%, the time required is 3 T half. Okay. So this is the amount which is 12.5 given in the question, which is present after 3 half-life. This is the amount present after 3 half-life. Okay. So what I need to do, what we have to do, so the concentration of the reactant is reduced to 12.5 in 1 hour. 1 hour means it is 60 minutes. And after 3 half-life only, we are getting this amount. So I need to divide this by 3. Okay. I need to divide this by 3. So T half is equal to T by 3. So T is 60 and divided by 3. I'm applying this formula to find out the value of T half. So it will be 20 minutes. Will be 20 minutes. Got it? So this is the value of T and we are calculating the T half here. All right. So very easy. So answer is option B. Answer is option B. Now coming to question number 72. The half-life period of a first order reaction is 10 minutes. So T half is given as 10 minutes. Starting with the initial concentration 12 molar, the rate after 20 minutes is. So first of all, let me write the given value. So the given T half is equal to 10 minutes. Okay. For first order reaction, the T half formula is equal to 0.693 divided by K, from which K is equal to 0.693 divided by T half. And T half is given in the question. Just substitute to find out the value of K. It is 0.693 divided by 10, which is equal to 0.0693. So this is the value of K. Okay. So this is the value of K. So why we have calculated the value of K? We need to find out the rate. Okay. And we know that the rate is equal to K into the concentration of the reactant. Let me take the reactant as A. Since it is a first order reaction, the order will be 1. So to find out the rate, I need the value of K. So that's why I have calculated. Now we have to find out the concentration at 20 minutes. Okay. At time T is equal to 0, initially the concentration of the reactant is 12 molar. Now at T half, after 10 minutes, okay, after half-life period, the concentration would have been reduced to half of the initial concentration, which is 6 molar. Now we have to find out the rate after 20 minutes. So at time T is equal to 20 minutes, so what will happen? The concentration will still get reduced to half of this value, right? Which is 3 molar. So at time T is equal to 20 minutes, concentration of the reactant is 3 molar. So we can substitute this in this equation where K is 0.0693 and the concentration of A after 20 minutes is 3 molar. And we can multiply this, but in the options, we just need to find out this. It is given in option C. Okay. 0.0693 into 3 molar per minute is the rate after 20 minutes. Okay. Now coming to question number 75. The correct electron gain enthalpy order of the chalcogens are. So chalcogens are basically the group 16 elements. Chalcogens are group 16 elements. So group 16 elements are oxygen, sulfur, selenium, tellurium, and polonium. Okay. So electron gain enthalpy will decrease on moving down the group. Okay. So what is electron gain enthalpy? The energy released from an isolated gaseous atom once the electron is getting added to it. Okay, if I'm adding an electron to an isolated gaseous atom, some amount of energy will be released from that atom, and that energy is called as electron gain enthalpy. Okay, so on moving down the group, it decreases. This is the general trend observed for all the group elements. Okay, but for 16th group, we do have some exceptions for oxygen and sulfur. Oxygen will have the less value compared to other elements of its group because of its size. Oxygen has less value compared to the other elements of its group because of its small size. Because of its small size. Okay. So because of its small size, repulsion will be more. So we cannot add an electron easily to oxygen. So this is oxygen and this is sulfur. Oxygen size is small, sulfur size is little bit big. Oxygen will have 2p orbital, sulfur will have 3p orbital, which is bigger in size compared to 2p. Okay. So if I want to add an electron to 3p, it is very easy because the size is bigger. Electron repulsion will be less. But in case of 2p, if I want to add an electron repulsion is more in case of this 2p. So we cannot add an electron that much easily. Okay. So we follow sulfur, selenium, tellurium, polonium, and at last only oxygen will come. Okay, because of the size factor and the repulsive factor. So option C is the correct answer for this question. Okay. Now moving on to question number 80. Which among the following is most acidic? So how to find out the acidity? If the oxidation state is higher, higher the oxidation state, higher is the acidic character. Right? So higher is the acidic character. Oxidation state is directly proportional to the acidity. Okay. So if you go for option A, manganese is having +2 oxidation state here. Because oxygen has -2, manganese will have +2. And in case of option B, I have for Mn2O3, I have 2 manganese to 2x. So 3 into -2 will be -6, which is equal to 0. 2x is 6 and x is equal to +3. So the oxidation state of manganese here is +3. Then in case of manganese dioxide, so manganese is taken as x, -4 equal to 0, x is equal to +4. So here it is +4. Then in case of Mn2O7, we have 2 manganese, so 2x minus 7 into -2 is 14 equal to 0. 2x is 14 and x is equal to 14 by 2, which is +7. So now if you compare the oxidation state of manganese in all the options, option D is having the highest oxidation state value. So that compound is more acidic in nature. Okay. So option D is the correct answer for this question. Clear? Moving on to the next. Question number 83. The spin-only magnetic moment of nickel 2 plus in aqueous solution would be. So in aqueous solution, nickel reacts with the water ligand. Okay, 6 moles of ligands of water will come and coordinate with the nickel and it is present in its 2 plus form. Now here we need to find out the magnetic moment of nickel 2 plus. Mu value we have to find out. Okay. So to find out the mu value, we need the electronic configuration of this nickel. So the nickel 2 plus electronic configuration would be 3d8 and 4s0. Right? So in the 3d orbital, we have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And if you see to the number of unpaired electrons, it is equal to, number of unpaired electrons is equal to 2. So to find out the magnetic moment, the formula is n into n plus 2, which is equal to root of 2 into 2 plus 2. So which is equal to 8, root 8 Bohr magneton. So the magnetic moment is root 8 Bohr magneton. Option C is the correct answer. Okay. So coming to the next, question number 85. The sum of coordination number and oxidation number of the metal M in the complex is, and En is the ethylene diamond, C2O4 is the oxalate ligand. So this is the metal M, ethylene diamond and oxalate. Both are bidentate ligand. Ethylene diamond as well as C2O4 2 minus. Both the ligands are bidentate ligands. Okay, bidentate ligand means one ligand will have two donor sites. So we have 3 ligands. So 3 into 2 will be 6. So the coordination number will be 6. Coordination number will be 6. Okay. So let me draw the structure. Suppose if this is one ethylene diamond and this is the other ethylene diamond. This one is the oxalate ligand where I have C2O4 2 minus. So it will not come like this. Here we have to write the carbon. So it is C2O4 C2O4 2 minus. Okay. So this is the oxalate ligand and you can see that there are 6 donor sites for these 3 ligands. So coordination number is 6. Now if I calculate the oxidation state, so the metal is taken as X. Ethylene diamond is a neutral ligand. So it will be 0. And for each oxalate, the charge is -2. So -2, and for each chlorine, it is -1. So -1 equal to 0. So X is equal to 2 plus 1, which is 3. 2 plus 1 is 3. So the oxidation state is +3 and the coordination number is 6. So 6 plus 3 is equal to 9. So 6 plus 3 is equal to 9. The sum of the oxidation number and the coordination number is 9, in which option D is the correct answer. Okay. Now coming to question number 87. Which of the following will exhibit maximum ionic conductivity? So the one which is producing more number of ions will have the maximum conductivity. Okay. So the number of ions produced is directly proportional to the ionic conductivity. So now we have to check with the number of ions produced in each case. So in case of K4FeCN 6 times, the ions produced is 4 potassium, 4 K plus, and FeCN6 4 minus. Okay. There are 4 cation and only 1 anion. So So the total number of ions produced is 5 ions. Okay. And in case of option B, we have CO, NH3, 6 times, Cl3. So it will get dissociated as CONH3 6 times 3 plus 3Cl minus. So there is 1 cation and 3 anion. So the number of ions produced is 4. And in case of option C, CuNH3 4 times, Cl2, I have CuNH3 4 times 2 plus and 2Cl minus. So there is only 1 cation and 2 anions produced. So the total number of ions produced is 3 ions. Whereas in case of option D, nickel tetracarbonyl, so there is no formation of any cation or anion. So then no ions are produced. It is a neutral complex. Okay. So if you see to the observation, option A has more number of ions. So it has the maximum ionic conductivity. So option A is the correct answer for this question. Okay. Now moving on to the next question, question number 89. The IUPAC name of the complexes. So we have 2 ligands attached to the metal cobalt. One is amine, other one is chlorido or chloro. So if 2 different types of ligands are present, then we have to follow the alphabetical order, right? So first comes amine. So we have 4 amine. So it is tetraamine. So it is tetraamine. And we have 2 chloro. So it is dichloro. And the central metal atom is cobalt. Oxidation state will be, cobalt is taken as X. Amine is a neutral ligand, so 0. Chlorine is an anionic ligand with -1 charge. So we have 2 chlorine inside the complex, so it will be -2. And 1 chlorine out. So it is -1, which is equal to 0. And X is equal to +3. So the oxidation state of cobalt is +3. So this is the cationic part of this complex. And outside the coordination entity, we have one Cl, which is called as chloride. So I have to leave some space and I have to write the chloride. So it is tetraamine dichloro cobalt 3 chloride. Okay. So it is given in option B. Option B is the correct answer for this complex. Okay. Now coming to the next 93. The complex ion having minimum magnitude of delta O is. So to find out the magnitude of this delta O is actually called as octahedral field splitting. And the magnitude of this splitting can be calculated using the ligand. Okay. So we need to find out whether the given ligand is a strong field ligand or weak field ligand first. So let me take the spectrochemical series according to the spectrochemical series. The order of the ligand will be, so we have NH3, H2O, Cn and Cl in the given 4 option. So Cl minus will take the weak field side, then comes H2O, then NH3 and then Cn minus. So where Cl minus is a weak field ligand and Cn minus is a very strong field ligand. Okay. So weak field ligand will create or it will have less splitting. But strong field ligand will create more splitting. Okay. So it will create more splitting. So the maximum magnitude of delta O is observed for Cn minus and the minimum magnitude of delta O is observed for Cl minus. So the Cl containing option is D. Option D is the correct answer. Weak field ligand will have minimum magnitude of splitting, which is delta O, and the strong field will have the more splitting magnitude. Okay. So this is how we have to calculate. Then coming to question number 95. If a first order reaction is completed to the extent of 75% and 50% in time intervals T1 and T2, what is the ratio T1 is to T2? So using the first order rate constant relation, I have to find out the time for both the percentage. First, let me go for 75%. So the T of 75 will be equal to 2.303 divided by K into log of A by A minus X. A is the initial concentration, which is 100, and A minus X is the remaining concentration, which is 100 minus 75. Okay, so it will be 100 divided by 25, and the answer will be 4, log 4. Then coming to T of 50%, it is 2.303 by K into log of 100 by 100 minus 50. So the answer will be 100 by 50, which is 2. Okay. So now we have the ratio for 75 and 50 as log 4 by log 2. Okay. Now since log 4 can also be written as log of 2 the whole square, the answer will be 2 into log 2, right? So this is a format, log of m to the power n. So the formula is n into log m. So this is a mathematical logarithmic formula we know, and using that I am calculating this as 2 into log. Now in place of log 4, I can substitute 2 log 2. Okay, so I can take this relation. So log 4 can be written as 2 into log 2 divided by log 2. So log 2 will get cancelled with each other. So from this, the T of 75% divided by T of 50% is equal to 2. Okay, so the ratio of T1 to T2 is 2. So option C is the correct answer for this question. Okay. Now coming to question number 99. Which of the following solution containing components A and B follows Raoult's law? So yeah, the solution which obeys Raoult's law is called as ideal solution. Okay. Solution which obeys or which follows Raoult's law is called as ideal solution. Now for ideal solutions, the force of attraction will be equal. Okay. The force of attraction will be equal. Suppose if I have two components, force of attraction for two components will be equal. Like AA interaction will be equal with the BB interaction and also will be equal with the AB interaction also. So the attractive force remains same for all the three. Okay, so this is the force of attraction for ideal solution. And also the delta V mixture is equal to 0. Delta V mixture is equal to 0. Delta H mix is also equal to 0. So everything will be equal to 0 for this ideal solution. Okay. So now moving forward with this concept, if I check for option A, so AB attraction force is greater than. No, it is not greater. And coming to option B, it is less than A and BB? No. And option C says that AB attraction force remains same. Yeah, it is same with the other. That is correct. And option D says volume of solution is different from the sum of volume of solute and solvent. Suppose if A is a solute and B is a solvent, option D says that sum of volume of solute and solvent is different from the total volume of the solution, which is AB. No, it is equal to 0. If it is going to be equal to 0, then the volume is also going to be same only. It is not different. Okay. So now option C is the only correct answer for this question. Okay. Now moving on to the last question for this session, which is question number 100. The molarity of 98% H2SO4 by weight is. So density of H2SO4 is given and the concentration is given in terms of mass by mass percentage. W by W. Okay, so what is the meaning of this? 98% mass by mass H2SO4 means, it means 98 gram of H2SO4 is present in 100 gram of the solution. So this is the meaning for mass by mass. Okay. So mass of the solute is given. Mass of the solution we have. But to find out the molarity, what is required? So molarity is equal to the number of moles of the solute divided by volume of the solution in liter. Okay. Or I can, if I'm going to take this in terms of milliliter, then I can multiply this by 1000. This is the formula. So number of moles and volume, both the thing we need to calculate. First, let me go for the volume calculation using the density value. So density is equal to mass by volume, from which the volume is mass by density, which is equal to the mass of the solution is 100 and the density of the solution is 1.8, which will be equal to 55.55 milliliter. Okay, because density is given in terms of milliliter. So the answer is in milliliter. So I have got the volume value. Now to find out the number of moles, we have a formula, right? The given mass divided by molar mass. We can use this formula to calculate the molarity. Therefore, molarity is equal to the given mass of the solute, which is 98, divided by molar mass of the solute. So to find out the molar mass, I am going to take this H2SO4. So I have 2 hydrogen. So for 1 hydrogen, the atomic mass is 1. For 2 hydrogen, it is 2. And I have 1 sulfur. The atomic mass of sulfur is 32. And I have 4 oxygen. For each oxygen, it is 16. So 4 oxygen means it is 16 into 4. So it will be 24, 64. So for 4 oxygen, it is 64. Now if I calculate, I will get 98 as the molar mass of H2SO4. Okay. So let me substitute that. And the volume is 55.55 into 1000. Okay. So 98 will get cancelled with each other. And 1000 divided by 55.55 is equal to 18 molar. Okay. Which is the molarity of 98% H2SO4. So option B is the correct answer for this question. Okay. So you just need to memorize the molarity formula and we have to find out the terms required to solve in the molarity formula. And since both the terms are not given in the question, we are finding out using the given relation. Got it? So I hope this session is very useful for all of you who are watching, and I'll meet you with the next set of questions in the next session. Until then, take care. Thank you so much. Bye.